Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, working on the unit number 5, lesson 4, talking about functions and graphs and equations. So it says, notice and wonder, doubling back. What do you notice and what do you wonder? So it gives you a graph on the picture here, and what I want you to do is think, pair, share. So what that means is I want you to pause, work with your partner, and share with the class what you think is going on with this graph. And I'll write some of these on the board. On the next part, it says three of these functions are, three of these graphs are functions, and it says to match each of these equations with one of the graphs. So it says d equals 60 times t, where d is the distance in miles that you would travel, t hours if you drove at 60 miles per hour. So what we can say is we can actually say this one goes with that graph B, and we know that because if we look at our equation d equals 60 times t, we could plug in some values and we should get, just past 50 miles is going to be 60 miles and for every 1 hour that you drive. For the next one, it says q equals 50 minus 0.4 times d, where q is the number of quarters and d is the number of dimes, and a pile of coins worth $12.50. So we could say that one goes with that graph C. And we know that because we can say, hey, what do you notice? Well, this one has a negative slope. So we can actually say this one has a negative slope. Let me actually write the equation here. So it says 50 minus 0.4 times d equals q. And for that first one, we could say that one actually just has a positive slope. However, for the last one, or that graph A, I can say that's going to be a non-linear function. And I know that because it's not a straight line. So that means not straight line. So as long as it's a straight line, it's going to be a linear function. But for our purposes here, we can say, hey, this is going to be area equals pi times the radius squared. So it's either a straight line, and also the other thing too is you can see since it's something squared, or that independent variable is squared, we're going to have a quadratic looking shape, or at least it's going to have a curve to it. All right, underneath of that, we have those same graphs, but what we're going to say is we're going to label each of those axes and write the independent variables and what they represent. So what I'm going to say is I'm going to say for this first one, I can say that r is going to be the independent variable where it's the radius in centimeters, and a is going to be the dependent variable where it's area in centimeters squared. Then I can say for this next one, I can say I have this is going to be t is going to be the independent variable where it's time in hours, and then d is going to be the dependent variable where that's distance in miles. And for the third one, when we're talking about dimes and quarters, we can say that d is going to be our number of dimes, which is going to be the independent variable, and q is going to be our dependent variable. So always just remember a way to think about it. So let me actually move this to the side here, like so. Just always remember when you're thinking of x, our x values is independent and dependent variable, or let's say x-axis, and we could say our y-axis usually is going to be our dependent variable. So just make sure that that's an easier way to remember about it. So let me try variable. Okay, so now that you have those labels, we can move on to number 3. So it says for each function, what is the output when the input is 1? So we need to plug in 1 into each of those equations. It says what does it tell you about those situations? And we can label those points in the graph. So let's say for this first one, that area of the square area of the square. We're going to say, if we plug it in, we're saying a equals pi times the radius, which is going to be 1. We say squared, which is going to be just equal to just 1 pi. So what that means is when the radius is 1, the area is pi. Or not write pi, let's say like our value or our symbol for pi, and we could say pi centimeters squared. Okay. So that's for that first one. For that second one, let me do in, let's do in pink, why not? Or sorry, let me plot that point on the graph. So find that point 1 and go up, and it has to be on the line, so we can plot it right there. We'll say that's going to be the point 1 comma pi. All right, let's do a similar thing for the next one. For our graph B, we're saying, okay, the distance is equal to 60 times the number of hours, which is 1. So we're going to say D equals 60 as just our value. We can say after traveling, and what that means is after traveling for 1 hour at 60 miles per hour, you traveled 60 miles. That makes sense because we're saying, you know, as you go 60 miles per hour, how long does it take to get you 60 miles? And we'll plot that point in the graph right here and label it. So we'll say that's going to be 1 comma 60. And for that last one, I'll do an orange. Plug in that value. We're saying Q equals 50 minus 0.4 times 1. And that means Q is going to be equal to 49.6. However, this is going to be a little bit trickier because, you know, it's almost like it's up here. It's hard to plot because our x-axis is it counts by 20s, so we'd have a weirder looking function. But that's okay because that the situation is just talking about number of quarters and dimes. So you can't really talk about, you know, 49.6 quarters because we can't have a part of a quarter, so we can just leave it like that. And for the last part, for number 4, it says find 2 more points. So what we can do is this. I can make a table. So I'm going to say I have R and A. I'm going to say, all right, 2 more points. When R equals 2, our area is going to be 4 pi. And when R equals 3, our area is going to be 9 pi. Let me make sure that that is on the screen. Yes, it is. Just barely on the screen, but that's okay. So we can plot those points out. We can say we have 2, that's going to be 2 comma 4 pi, and 3 is going to be 3 comma 9 pi. So just make sure you're plotting those points on the graph. Same idea with the next one. Let's do it in pink again. We'll have another table. We're going to say our table is going to be T, whereas that's the independent, and the dependent is D. So we're going to say another point that we can do is going to do 2 comma 160, and, or sorry, not 160, let's do 120, and we can do 3 comma 180. And some other values we can have for the last equation is we can use, what was it, dimes for D and Q for quarters. So 2 more points, we can say 40 comma 34, and we can say 80 and 18. So again, just be able to plug in those values, and you're plugging in the x values into your function. So similar to what I did here is I plugged in 40 in for D, and I solved for Q. Alrighty, on the back, we're going to be talking about running around the track. So it says Kieran was running around the track. The graph shows time t, and then he took to run various distances d. Then it says the table shows his time in seconds after every 3 meters. So notice how it has the x-axis as distance and the y-axis as time. So make sure you're kind of keeping that in mind. So it says for part A, it says how long did it take Kieran to run 6 meters? Well, let's find out. So let's do red this time. So 6 meters, so our distance is 6. So we'll say when d equals 6. So when d equals 6, our time t is going to be 2 seconds. Then it says for the next one, how far has he gone after 6 seconds? And now we're finding when t equals 6, what do we have? So we have to find our value where t equals 6, and it's right here. So when t equals 6, we can say d equals 18 meters. So make sure you can, be very careful when you're reading that table and that graph, be able to switch between it and make sure it tells you what you're looking for. So then it says estimate when he had run 19.5 meters. Well, let's find out. So our distance is 19.5, so we can say it's in between. So let me actually say it's in between 18 and 21 meters. And that means that we can say it's in between, well, if it's in between 18 and 21, that means for seconds it's going to be in between 6 and 6.9. So that means between 6 and 6.9 seconds. I'm going to give an estimate. I'm going to say, well, if I take the difference divided by 2, I can say, well, that's going to be about, or sorry, I take the sum divided by 2, I should say. I would say about 6.45 seconds. Again, it says to estimate, which is what we did. And it says to estimate how long it took for 4 seconds. Well, we can say, if you're looking on the graph, it'd be just about right here. So let's find our graph. So it says about 4 seconds. So it has to be in between 3 and 6, but it's going to be, between 3.8 and 4.6. But what you can do is you can use that graph. So we said, hey, 4 seconds is right here. Pull out a point on the line. We can say it's about right there. So it's just past 12. So we can say approximately or about, we can say it's about 12.75 meters. And it says, is Kira's time a function of distance that he's run? Explain how you know. So we can say, well, how do we know if it's a function or not? So function, again, function means no repeated x values. And that's exactly what we have since it is, let's try that again, values, there we go. Since there's, each x value or each distance has its own time, then we could say that that's going to mean that it is a function. So we could say, this one, we could say yes. We could say yes. And let's say you can use the distance. Let's actually type this out. Let me actually type this. All right, so we're just going to say at the bottom part, we're saying, yes, you can use the distance he has traveled to find the time it took him to travel it. So each of those distances has its own time. That means no repeated x values. That means this is a function. Moving on, it says Priya is running once around the track. The graph shows her time given, how far she has run from the starting point. So this is actually from the warm-up too. So some things you can notice or wonder about it might come into play now. So it says, what is our farthest distance from the starting point? So we have to look on our x-axis and say, hey, well, if we look at the furthest to the right, that's going to be about 200 meters because it's counting by 25. So we're going to say that's going to be 200 meters. Then for the next one, it says estimate how long it will take her to run around the track. Well, we say, if we notice, it goes to the far right and then to the far left. So about right here is going to be about 75 seconds. So we're going to say 75 seconds for this one. That says to estimate when she was 100 meters from the starting point. So we can find on our graph, find where 100 is, and I can say, well, I have one point here and another point here. So approximately, so we can say at about 18 seconds, and try that again, and 54 seconds. So it's not just one place, but it's at two places actually. So then it says to estimate how far she is from the starting line after 60 seconds. So about 60 seconds, find that point. So we're saying from 60 seconds, use that x value. So we're going to say 75 meters because we get that from that bottom point. And then for the last part, it says, is Priya's time a function of her distance from the starting point? Explain how you know. And so for this one, we're going to say no. Since there are two times that she is 100 meters from the start, it is not a function, meaning it has repeated x values. So it cannot have repeated x values for it to be a function. All right. And then on the next page, some practice for you, a couple questions, real simple. It says the graph and the table show the high temperatures in a city over a 10-day period. And that says what was the high temperature on day 7. So let's find it out. So let's find day 7. So that's day 7. And so that's going to be 60. Or if you want to, you can use the table. I personally like to use the table. It's a little bit easier to read. So I'm going to say it's going to be 60 degrees. Then it says which days have a high temperature of 61 degrees. So we're going to say day 2, day 4, and day 6. So day 2, 4, and 6. And it's saying, is temperature a function of the day? We can say, yes, it is. We're going to say, yes, there are no repeated x values. And that just means if we look at our x values, each day is unique, so we don't have to worry about any repeated points like that. But what happens is, for the next part, it says, is a day a function of the high temperature? And explain how you know. So for this one, we're going to actually say no. We're going to say no, and the reason why we say that is if we switched the axes, then there would be repeated x values. So, and we know that would be repeated because if we look, notice how it has, just from that part B, we have 3 values that are 61. And so if we switch to the axes, we would have repeated x values, which makes it not a function. And then for part 2, it says the amount Lynn's sister earns at her part-time job is proportional to the number of hours she works. And anytime they see that word proportional, that just means it's going to be like this type of equation. And it goes through the point, through the point 0, comma 0. So it's proportional to the number of hours she works, and she earns $9.60 per hour. Part 8 says write the equation in the form y equals kx to describe the situation where x represents the hours she works and y represents the dollars she earns. So we can say for this one, real easy, we're going to say y equals the amount that she earns, so $9.60 for every hour. However, now it says if we have y, is it a function of x? So we're going to say yes it is. We're going to say yes. We're going to say there is only one input for every output. What that means is no repeated x values. And then for the last part, it's saying try to write an equation where y is the independent variable. So we're going to switch it around. We're going to say x equals, and then we can say y divided by 9.6. So again, just trying to set x equal to itself, we would have this as our new function. All right. For number 3, it says use the equation 2x plus 4y equals 16 and be able to graph it out. So what I'm going to do first is I'm going to complete the table. A couple ways you can do this. You can either plug in and solve, or you can graph. So let me show you what happens when you plug in and solve. So for example, if I said x equals 0, I would say 2 times 0 plus 4y equals 16. And this becomes 0, so this goes away. 4y equals 16. Divide both sides by 4 to get y by itself. We would say y equals 4. So that's one way of doing it. The other way is graphing it out, which I will show you here. I pull up my Desmos calculator, and it's saying, okay, if you have your equation 2x plus 4y equals 16, graph kind of looks like this, and we're saying plug in the points when x equals 0. When x equals 0, notice how it graphs that orange line. It's saying, okay, what is your y value at that point? At the point where x equals 0, your y value is 4. So as long as you can change it like that, you'll be good. So let's do another one. Let's do the next one. When y equals 3, notice how it's a horizontal line. What's my x value? Well, that's going to be 2. So I'm going to say for this one, it's going to be 2. Let's switch back. Let me say when x equals -2. When x equals -2, what's my function, or what's my y value? It is 5. So let me write 5. And when y equals 0, what is your x value? It's going to be 8. So notice how I'm able to find each of those values by graphing it out. So try making sure that you can graph that out using Desmos, but then being able to find where those points intersect. All right, then make sure you can graph it out on your points given. So I'm actually going to graph out these 2 points. I'm going to graph out the points. So graph points. Let's graph out the point 0, 4 and the point 8, 0. Again, any 2 points work out, but I like those 2 points because they're on the x and on the y-axis. Graph those 2 points. Once you have those 2 points, you can draw the line through those points. So let's say something like this. Let's go here to here, maybe. Let me try that again. Go through those 2 points. And let me extend it out on this one. Like so. All right, so just make sure you can draw a line through those 2 points, and then it should go through those points that we had. So a way to check is if I look at the point -2, I should be at 5, which is good, and at 0, 4. What about 2, 3? That's on the line as well. And 8, 0 is there as well. So notice how those points are directly on the line, and we know it's good. All right, and for the last one, it says solve the system by graphing in Desmos. Write the solution as an ordered pair, and again, that's just an x and a y value. So this time, make sure you can pause for your turn. Again, real simple, graph it out, find where they intersect, write that point down. Be sure to flip it over and do the exit ticket as well. Be sure to ask questions and check with me. So, and check, make sure it's showing, yeah. Check with me. Otherwise, make sure you can replay and rewind and use those subtitles. And as always, super slam that subscribe button.